My name is Felienne. I'm assistant professor at Delft University of Technology in the Netherlands, and it's my job to keep you awake for the rest of this hour that the conference still lasts, so I hope I will at least succeed in doing that. And I want to talk about teaching programming, because in my job as a university professor, half of the time I'm teaching university students to program. And on the other half of my university duties, I do scientific research, and my research is also about teaching. It's about how to teach young children, elementary school age children, programming. So it's fair to say that I spend most of my time either doing education or thinking about education. And in this talk, I want to share some of my insights with you. But first, a quiz. It's a good way to keep you awake. Who said this? Who said everyone should learn programming? Any guesses? Steve Jobs, Bill Gates, other guesses? Everyone. Thank you, Phil. Yes. I like to think every programmer ever has said that. I mean, I've said it, and I'm sure a bunch of you have also said, everyone should learn programming. You know, we love programming, so sure, kids should also do programming. But this, of course, brings a very interesting question with it, and that question is, what is programming? What do we say if we say everyone should learn programming? It's not an easy question. It's not as easy as you might think. If you ask 10 programmers what programming is, maybe you will get 10 different answers of what programming means to people. And this is especially hard, the question of what is programming, because we as programmers, as professional programmers, we are programming all the time. And that gives us a certain perspective on what programming is. It reminds me of this joke of three fishes, maybe you know it. There's this one big fish, he's swimming, and he runs into two other fishies, and he says, "Hey fishies, how's the water?" And the two little fishies say, "What's water?" They don't know what water is, because the only thing they know is water. They're always swimming in water, so they don't know that there's a difference between everything and water. They don't know that they could be yanked out of water and not be in the water, and that wouldn't be a very pleasant experience for them. In a sense, this is also how many programmers think about programming. At least this is how I thought about programming for a long time. The only thing I knew was programming. The only community I knew was programming. And that gives you a certain view on programming. So for the first part of my talk, I want to share with you my story into what I see as programming and how that has changed over the years. So we have to go back in time to the year 2008, when I moved from Eindhoven, where I did my master's degree, to Delft, where I was going to do a PhD. And our country is tiny, so this move is about 150 kilometers, so probably for you that's nothing, but for someone from a tiny country, this is a big move. And I went to Delft to do a PhD at TU Delft, the University of Technology, and the research question for my dissertation was this. My supervisor had the idea in mind to build a DSL, a domain-specific language, specifically for finance. So a programming language, but not for professional developers, but for people in finance, insurance people, bankers, to write their own programs so that they don't need a programmer for everything. So this is more or less what we envisioned. A programming language that was easy enough for people that weren't trained as professional programmers to express their business rules. So I went out to do a small internship at a Dutch insurance company. And remember, I just came out of school. I only had a master's degree. I have never worked in practice. So my view of the world was more or less this. This is what they told me in university. There are programmers and there are users. And there's a big wall between users and programmers. They are a different species. They don't really mix very well. And sometimes you have to listen to users a little bit to know what you have to program. And then quickly you'll go back to programming land where you'll do some programming. I'm not sure if they still teach this in universities, but this is at least the mindset that I grew up with coming from university. This image was quickly shattered running around in this insurance company, because I figured out that it wasn't the case that programmers program and users use. They all program. The programmers programmed and the users also programmed all the time. However, it wasn't how we envisioned being in the ivory tower of the university, that the users programmed in a textual language expressing their business rules. All the users were programming in spreadsheets. They were all using spreadsheets for everything, running risk models, doing budgets, doing forecasting. They were all programming in spreadsheets. So I went back to the university and I said to my PhD supervisor, I said, hey friends, they don't need a DSL in finance. They have a DSL in finance and it's called Excel. Excel is an amazing programming language that empowers normal people to do programming in a variety of different domains in finance. So this became the motto of my PhD dissertation. Spreadsheets are code. Spreadsheets are a valid means of programming. They are, in a sense, and I say this with a little bit of humor, but also in full seriousness, spreadsheets are the best programming system that has ever existed in the history of programming. Spreadsheets are such a good programming language that people don't know that they're programming. People will find you. They will say, oh no, I'm not programming, I'm just making a spreadsheet. I'm just making a little model. Well, while of course they are programming without even realizing it. I mean, imagine doing Java by accident. It's like, oh, Eclipse just showed up on my machine and I opened it up and it looked very intuitive and friendly and I immediately figured out how it worked. But this is true for spreadsheets. You can open a spreadsheet and you can more or less figure out how it works and you can pick up programming skills as you go. So I see it, as I say, in all seriousness, spreadsheets are an amazing programming tool. Not only are they code, they are functional programming. You know, we're at the functional programming conference. Think about it. The only thing a formula in a spreadsheet can do is take input from other cells and calculate the results based on those inputs. A spreadsheet formula is side effect free by definition. It cannot access other cells in the spreadsheet, so it's functional programming. If you like buzzwords, I have another buzzword for you. Spreadsheets are reactive programming. You know, you update the formula, a cell in a spreadsheet, and the other formulas that depend on the cells, they just update. It's a reactive functional programming system, and yet 750 million people can use it without any issues. Eat that, Haskell. It is functional programming for the masses. It is really a serious programming language that enables lots of people to do programming. So again, this was the motto of my PhD dissertation, spreadsheets are code. However, what I zoomed in on was the issues around spreadsheets. Spreadsheets don't really have the IDE support that we are used to in professional language development tools. IDEs usually have support for refactoring, for smell detection, for visualization, and spreadsheets don't really have that type of support. Well, sometimes spreadsheets can need those type of supports. We've seen spreadsheets that had 150 worksheets all interlinked with formulas going everywhere, and it was very hard for people to figure out how exactly it was structured and whether it was structured well or not. So that is what I looked at in my dissertation. Mainly, I focused on the idea of code smells in spreadsheets. So code smells, if you're not familiar with the concepts, are parts of programming that aren't necessarily a bug, but they aren't really structured very well. So an example of a code smell is a long method. A long method can be fine, it doesn't need to contain bugs. However, we've all seen these 1,000-line methods. They're not really pleasant on the eye. They are more error prone. They will take people longer to really figure out what's going on. And another code smell that's common is duplication, also sometimes called code cloning, where you have similar functionality across a code base, and then if you need to change one duplicated item, maybe you also need to change the others, and you can introduce bugs that way. We can see how these type of smells can also occur in spreadsheets, because similarly to a long method, you can have a long formula, which is smelly for the same reason. It's very hard to understand what is going on. And also duplication, formulas can be duplicated in different parts of the spreadsheet, and then if you change one, maybe you also need to change the other ones and you can make mistakes. So in this sense, it's quite intuitive to translate code smells as they were defined by Martin Fowler to spreadsheet formulas and write tools that help people to find and improve the smells in spreadsheets. And that's exactly what I did in my dissertation. So I wrote a bunch of papers about smells in spreadsheets, and then I got my PhD. So that was a fun story, and I shared this story many times at many developer conferences where I talked about, hey, you know, spreadsheets are code and it's really cool and I'm writing a thesis about it. But this is sort of the story from my brain. These are facts, they actually happened. It's not a fake dissertation, it's a real dissertation. It actually happened that I did these things, but it's only part of the story because there's also the story of the heart. How was I feeling while I was doing this, and how was I reflecting on the world around me while doing my dissertation? And it started off really fun. So I went to lots of developer conferences like this one we're at right now, and I went everywhere and I said, hey, spreadsheets are code. It's so cool. Spreadsheets are code. And then people be like, yeah, it's not real programming. And I was like, yeah, no, you're wrong, listen to me. But they're functional, and they're reactive, and they're really cool, and it's spreadsheets and code, and people be like, yeah, it's not real programming. And it's sort of fun. It's fun to be the underdog for a while, but after a while, it eats at you. It's really tiring to tell the same story. So I sort of got sadder and more tired without really realizing what was going on. I was just losing my energy because I was like, look, it's programming. Look, it's right in front of you. It's an if statement. They'd be like, no, it's not real programming. And later, like 3 years later, I realized that not all communities are like this. When it was 2012, when I was graduating, I really thought the way that normal professional adults interact with each other is they just bitch to each other about their tools all the time. This is normal behavior in communities. That's what I thought. So now I'm also part of other communities that, this may surprise you, are not like that. I'm also running now, and I'm not a good runner. I'm actually quite a slow runner. My quickest half marathon is 2 hours and 15 minutes, and the full marathon world record is 2 hours. So I'm more than twice as slow as the quickest people on the planet. But that doesn't matter to other people that are running. If you're running, or you just mention you're running, other runners will come up to you and they'd be like, oh, you're a runner, that's so cool. What is your PR and what races are you doing? They don't care that you're super slow. They're not going to say, oh, you're running on Adidas shoes. Oh, they have security vulnerabilities. You know that, right? No, runners are like, cool, you're a runner, you're part of the club. They're not going to say, oh, you're so slow, 10 kilometers an hour. Pfft, we don't care about that. It's even worse. Runners are more evangelistical than Jehovah's Witnesses. Runners, if you know a bunch of them, they're all trying to actively turn other people into runners. If I see someone catching the train, I'd be like, oh, you're a runner, do you want to go on a race with me? Seems like you're having fun. Runners are trying to help other people be better runners, and they will never say something like, you are not a real runner. It's a ridiculous thing to even think about. And the same is part for the knitting community. So I used to do lots of knitting when I was a teenager, and then I didn't really do it for 20 years, and then I picked it back up, so I went to a few workshops with what I know now are very old-fashioned knitting needles. There are fads also in knitting, and now they don't use straight knitting needles anymore, but circular needles. I didn't know that. So you just come to your workshop with your old-fashioned needles, and no one says, oh, old-fashioned needles, you really need an update. It's just like, oh, happy that you are knitting again. Everyone is friendly to each other. Imagine my surprise, right? It is so weird. Why do we do this to each other? But, so I know that now that other communities can also be friendly and inclusive, but then in 2012, I didn't really know this. So I was sad and not really excited about my topic anymore, but I just accepted a job as university professor in Delft, so I needed to do research about spreadsheets. That's what I promised them to do, but I wasn't really into it. I was like, where's my life going? I'm so sad. Luckily, by networking, I knew people in my neighborhoods, and I found a community center close by with a bunch of kids that wanted to learn programming, and they were looking for a programming teacher. So I was like, yeah, I can teach a bunch of kids programming, then at least I'm doing something that's making me happy, and maybe I will stop worrying about whether spreadsheets are programming or not. So I went there, and at the community center, they had a little LEGO Mindstorms robot. Who's played with LEGO Mindstorms? To try it for your kids, right? I get it. So this is what we started programming because it was there and the kids really enjoyed it. And for those of you who haven't done LEGO Mindstorms, it's a visual programming environment. It really looks a little bit like this, where you have boxes that are connected with lines, and this is how you program the robots. So one Saturday afternoon, the kids have gone home, and I'm looking at those programs. I'm like, they're not really very well structured. They have some duplication in them and some unnecessary logic. I think I've seen something like this before. These are code smells in LEGO Mindstorms. The exact same thing that we saw in the financial people in spreadsheets, the same behavior I saw in the children with LEGO Mindstorms, because they were programming as a means, not as an end goal. An insurance person cares about a budget, a kid cares about getting the robot to drive. So they're not necessarily concerned with the beauty of the organization of what they're making, they just want to get it to work. So it's like, that's interesting. I could just write down something about code smells in LEGO Mindstorms. Just one paper, at least my department head will be happy that I'm producing research, even though it's not about spreadsheets like I promised in my research statements. A paper is a paper, so it should count for something. Of course, you understand that we're 20 minutes in this talk, so it wasn't just one paper. Because then, of course, I was curious, are code smells bad? Does it even matter to young children that programs have some code smells? Is this a problem? Maybe it's a problem for professional developers. It's even a problem for people in finance because the models grow so big that they get confused. But if it's just for kids, does it actually matter? So at this point, we moved to a programming language called Scratch. Who's tried Scratch for their kids? It's a visual programming language from MIT. And with Scratch, by the way, we did this on fresh kids, so not on the kids from the community center, but on kids from a local high school. You can't experiment on the same kids. After a while, they sort of understand what code smells are. So we had a bunch of fresh kids from a local high school, and we divided them into 3 groups. One group got perfect code that we designed as pretty as possible. One group got source code that has lots of long methods, so big blocks of source code stacked together. And the other group had code that suffered from duplication, so similar functionality in different places in the program. This is, by the way, how Scratch looks like. So it's a visual programming language. It has blocks. And here you can imagine how a long method would look like. That's a big stack of blocks instead of small parts that have functionality spread out. So on a game of Breakout, so a Pong-like game, we had these 3 versions that I talked about, a good version and 2 smelly version. And we asked children to explain the source code to us. So what is this doing? And we also asked them to adapt the source code. So the game would go until 5 points, and then it would play a little sounds. And we asked children increase the upper limit to 10 points. And of course, this is where the duplication was. So that made it a little bit tricky for the kids that got duplicated code. With this, we could answer the research question, are smells bad for children that are just learning to program? And the quick answer is yes. Code smells are also bad for novices that are just learning to program. The kids in the NICE group did significantly better on explaining and adapting source code than the kids in the groups with the code smells. Not surprising, but it was good that we found out that it actually makes a difference for young kids. So yeah, maybe 2 papers, or maybe 3. Because then we wanted to know, do these code smells exist in the real world? We made those 3 programs, of which 2 had code smells, but maybe, just maybe, children in the real world don't produce smelly codes. Maybe they're just perfect programmers and it doesn't really happen in practice. So the nice thing about Scratch is it's open source, you can use it for free, but also they have a public repository, which is a little bit like GitHub, where you can share your programs, you can even fork programs from other children. And this repository is also Creative Commons, so you can download all these programs and print them out, or tattoo them on your arm, or do static source code analysis on them, which is the most fun option, really. So we downloaded 250,000 programs from the Scratch public repository, and we analyzed those programs for the occurrence of a number of well-known code smells. What we found is that 30% of the programs in the public repository suffered from long method smells. So they combined a lot of those blocks in one stack rather than splitting out functionality where possible. So that's a number that's comparable to things we found on spreadsheets and on traditional textual languages. We also found that 26% of the programs in the repository suffered from some form of cloning, so copy-pasting functionality rather than creating abstractions, which is also along the lines of smells that we see in professional code bases. What we also found, and I didn't really understand it then, is that only half of the programs that we sampled had some user interaction. So only half of the programs did things like, if you click a button, a sound plays, or looking at the mouse, or looking at the microphone. The other half of the programs didn't have any user interaction. You would just start them, and then they would play a song, or an animation, or make a drawing. And we weren't really looking for that. We were looking for the code smells, but it was still like, this is a surprising finding. It doesn't really fit what I think about what programming is very well, because if I think about programming for kids, I think about games. Of course, they will have lots of user interaction because you're playing each other. It's like, that's an interesting finding. I'm not really looking for that, but it's stuck somewhere, like a piece of gum in your hair, like it can't get out. It's annoying me. What does this mean? So at this point, I thought, I haven't done spreadsheets in over a year. Maybe this is going somewhere. So we wanted to take it a little bit further. And the next research question that I answered is, can we teach children about code smells? If we explain code smells to young children, and this was from the age of 7, do they actually understand what code smells mean? If we explain to them, hey, don't stack 20 blocks together, split it up where possible, is this something that they can then recognize in source code? So we created an online course on the edx.org platform, a platform that's usually used for MOOCs, massive open online courses for university students and professional learners, but we used it to target 7 to 12-year-olds. And in the first run of this course, 3,000 children participated, so that was really nice for data collection. What we taught them is programming and smells together. So we said to the children, this is just a programming course. We'll just teach you programming. But secretly, every week, we talked about a programming concept, but also about a code smell. So duplication, a long method, and good naming. We talked about those code smells every week. And we did some moderate lying to the children because we said, this is how professional programmers do it. They like clean and efficient and neat source code. So this is how you should also do it. I hope they believe me. So with this, we could answer the question, can we teach children about code smell? And the quick answer is yes, we can actually teach 7 to 11-year-olds about code smells pretty well. On the questions we asked about programming, they scored about 72 out of 100 points, whereas on the questions related to smells, they scored about 85 out of 100 points. So these were questions like, is this code better than the other code, or what adaptation do you need to make the code cleaner or nicer? Of course, this only tells us that they understand code smells. It doesn't necessarily tell us that they will also not make code smells while programming in the future, but at least it proved that children are capable of distinguishing good code and bad code. So now, maybe almost 2 years in this, I'm not really doing spreadsheets anymore story, I figured out that this is my new topic. I'm not going back to this is not real programming land. I'm really interested in, can we teach children about source code? Can we teach children about code smells and everything else that is there? So at that point I thought, okay, maybe it's time to look back at what I have done so far and make a plan for where I want to go. Because how research normally goes, if there's such a thing as how research normally goes, is you have some sort of dot on the horizon that you're working towards. You have a goal where you want to go, and in small steps you're going there. But I didn't have any goal. My only goal was where I didn't want to go. I'm like, there are the spreadsheets, I'm going that way. But I didn't really have any goal. So after a bunch of papers, I was like, okay, I need to look back and see what is teaching programming all about. And of course, as I said in the beginning of my talk as well, if you say your research topic is learning programming, you have to think about what is programming, because everything you believe about programming is what you will end up teaching children about programming. So I was looking back and I was like, oh my God, I imprinted so much of my beliefs on children without really realizing it. I told children that programming is technology because we did the LEGO Mindstorms robots. I taught them that programming is games because we did the breakout game in the smell story. I told them learning to program is by making programs, because in the online course, I just said, hey, this is a game, and this is what we're going to make. Step by step, we're going towards this game. And every time, if you're teaching a child what programming is, you're also teaching a child what programming is not. So what I didn't tell them is programming is art and programming is story, and you could also learn programming by exploring different steps rather than building towards a big program from the beginning. So I realized I had lots of beliefs about programming, and I accidentally brought them into the classroom. And I wanted to do my best for myself to have less assumptions. That also goes back to this story where I said half of the programs have user interaction and the other half doesn't have user interaction. I was assuming that that half didn't exist. I was only concentrating on the game-like programs and not on the art and animation-like programs. So I started to think really heavily about what is programming. What does it mean for me? Why do I think that? What does it mean for other people? And why do I think that? Beware. I'm going to say controversial stuff. I'm putting my Twitter handle on the slides again, so if you disagree with me, send me angry tweets. Or you can also like nod or wave your hands, but in the interest of we all want to go home, I'm not doing responses at this time. But if you don't agree with me, feel free to send me angry tweets. Or leave now if you think you can't handle controversy. So what is programming? You can break it into a number of different dimensions, I think. I can also imagine there are other dimensions, but these are the dimensions I think are interesting. One question is, what is programming about? By which I mean, what do we program for? If we're programming, what will we apply the superpower that we have that is programming, what will we apply it on? So I would say that axis more or less goes from technology to the humanities. So things you can do that are very much in the technology space are toy robots. Maybe self-driving cars is still very much technology, but is moving a little bit towards the humanities because you can see how a self-driving car makes the world a better place more than a toy robot or a drone or something like that. And maybe all the way on the humanities side of the spectrum, maybe you have analyzing Shakespeare, which is, it's a valid use for programming. But if you think about what image programming has in general, these things are less likely. Another dimension is what is programming like? What other things that children or adults already know looks like programming? That's another way that we can frame programming. So this dimension more or less goes from programming is math towards programming is like creativity. And this is where Phil Wadler is. So nothing against Phil, but with his talks about category theory, that I've seen many times, and I'm still not sure that I really get it. We imprint a certain image on people what programming is. Programming is like math, and it's not necessarily a good or a bad thing, but it is a thing. We say it puts programming in a certain vicinity of other fields. Many intro courses are somewhere between programming is like math and programming is like logic. And Scratch, I think, the visual programming language that also allows you to make stories and animation, is a little bit more down on that spectrum. It also tells kids that programming can be very creative. So another dimension is what is programming for, which more or less goes to I'm programming because it pays my mortgage towards I'm programming because I wake up at night and it has to go out of my head. I'm programming because I want to express myself in a certain way. And you could say open source is on many places, I think, of the spectrum. Some people do open source because they think it will give them a good reputation and good chances on the job market. So it's still very much in the frame of coding for money, and this can be towards coding for self-expression. However, many open source projects, even though people do it for fun, they still create programs that have a use in the world, like a video player or a chat application. You still make something that has value that you could sell. You don't, but you could. So I'm not placing it all the way at self-expression. Something like end-user programming, for me, is a little bit closer towards self-expression because you're not programming directly to sell the source code for money. You're solving a problem that matters to you, and you use source code to solve the problem. So it's a little bit farther for me from the code for money spectrum. Who knows Sonic Pi? Oh, awesome. Lots of Sonic Pi fans in the audience. So Sonic Pi is a programming language that's meant for both children but also professional musicians to generate music with source code. And I think that's, at least what I know of, the thing that is most code for self-expression related. It's most, oh, I have this music in my head and I really want to get it out, or I will be inspired by the source code that I write. So these are a bunch of dimensions that can give programming a certain flavor. There's one more that I want to talk about, and that is who is programming for? And that's an axis that goes more or less from programming is for compilers to programming is for humans to read and enjoy. That's also a dimension of what programming is. So things like coding style and good naming are a little bit away from for compilers in the direction of coding for humans. Because at least if you're thinking about good names, if you're thinking about a proper coding style, then you're also thinking about humans, but not as far as we could. Literate programming, and that's the idea that mixes documentation and source code together. It's a quite old idea, but it's now maybe the thing we know closest to it that's in fashion is Jupyter Notebooks. It's a nice way of thinking about literate programming, where you mix source code and natural language. It's sort of in the middle between programming for the humans and programming for the compilers, because you mix text that is specifically for programmers and text that is specifically for the compiler. Closest, I think, to humans is non-executable explorations of source code. Source code doesn't have to be for compilers. That's just a thing we agreed upon. But if I really feel like it, why couldn't I say if, as a code poem? Who cares that it doesn't compile? If this is what I want to express, if I want to explore all the ways of iteration, I could write down many forms of iteration that don't even compile just to see how does that programming language feel to me? How does it make me feel? How does it feel for other people? And one of the person, I'm not sure if he's here, but someone that has really inspired me in this is Thomas. He said, when we were brainstorming about this in Cambridge years ago, he said, we should liberate programming from the tyranny of execution. Just like, yes, that really put me on the path of this thinking in many ways. Why should source code be executed? There is no reason that we would limit ourselves to one side of the spectrum. So we can combine all these axes together, and I'm not saying they're necessarily all orthogonal. I don't know how many dimensions this space should have, but I think we can more or less say that this is where the sea of reasonable beliefs lies. This is what most people focus on, what they mean if they say programming. They mainly mean programming is technology, it's math, it's something you do as a job, and it's partly for humans, but also very much for compilers. And as I said, if you don't agree with me, send me angry tweets. But this is something, for me, that's really interesting to talk about. What do we think is still ridiculous, and what do we think sort of middle of the road, what everyone believes? A thinking frame that has made me a lot happier thinking about programming and has helped me embrace the richness of what programming could be is the thinking frame that programming is like writing. I think that's a very liberating way to think about programming. And if you think about it, it totally makes sense that programming is like writing. I'm not the first to observe this similarity between those two fields. Ultimately, programming is you have an idea, like an app that tracks compliments. I would really like to have that. If someone says something nice, I'll be like, say that again while I record it, and I can play it back. It's this high-level idea that you translate into letters and sentences. That is what programming is, if you abstract away very far. The same is true for writing. You have this very high-level weird idea, like a frog murders foreign diplomats. You take that idea and you translate the idea into letters and sentences. So from that perspective, writing and programming are very similar. You have an idea, you write it down in a agreed-upon form, and then you read it, and then someone else can execute it in their brain or their machine, whatever they prefer. However, writing is also way broader than programming is. Because what is, if you go on the street and you ask random people what is writing, all these things are writing. Writing a dissertation, science. Writing a petition, participating in society. Writing a to-do list, purely practical for yourself. Writing fiction, for yourself or as a career, as a hobby. Calligraphy is writing. Just writing pretty letters is writing. Poetry is writing. Breaking grammatic rules to see what it does with your brain. No one has an issue that all of these things are writing. They're all writing. They're different, but they're all this umbrella. Why can't programming be this wide? Why can't thinking about how to write syntax in the prettiest way be also considered part of programming? That is interesting. And as I said, for me, this frame has made me happier to think about programming, because this language metaphor really helps to be inclusive and to get more people and different type of people interested in programming. Because the connotation that comes with programming writing is everyone can learn it. Everyone, almost everyone, knows a language, a natural language. Many people know 2 or more natural languages. So if you say programming is like learning a language, people be like, okay, I already did that once in my life, maybe twice. Probably I can do that again. Whereas if you say programming is math, some people will not really feel included. And this is not like a hypothetical idea that could happen. There's lots of research that shows that the more people believe that quality in a field is innate, is inborn, the less women participate in a field. So the more people believe that programming is like math, and about math, people believe that you need a certain skill set, you need to be born with it, otherwise you're never going to make it in math. Whether or not that is true for math is a whole different discussion, but that is a stereotype that sticks to math. And that stereotype makes women feel less included because they think, oh, I'm not born with the math gene, so I'm not born with the programming gene, so let's go do something else that I can learn. So this is really a frame of thinking that matters, and we could exclude people by emphasizing how much programming is like math. What I also really like about the programming as writing frame is that some stuff in writing, in natural language, makes no sense. Why? Because people invented and people made mistakes. So this is me as a 16-year-old learning English. So I'm like, hello, I can English. I read a book. And the teacher says, well done. You read a book, I read a book. Next sentence. Oh, I can do this. I've read a book. No, it's I've read a book. Why? Why is there inconsistency in English? There are languages like Dutch that have a one-on-one mapping from letters to sounds, but not English. Some things just don't make sense. Why is it I read a book and I've read a book? There's no other reason than that's how the language evolved. This is also true for programming. So here's some Python. One is a for loop, and the other is a list comprehension that also contains the keyword for. But in a loop, it ends with a semicolon, with a colon, and in a list comprehension, it doesn't. It's both for. It looks the same for something in range something. The one variety has a colon, and the other variety doesn't. I had one of the students in my Python class said that this was unfair, that the syntax was like this. And I was like, yeah, I hear you, friends. This is unfair. Why is that the case? And they were just studying for loops, and they think they get it. Okay, a for loop is for I in something, something, colon. Here's something that looks exactly the same. It's not. If you tell people programming is like math and like logic, and then you confront them with stuff like this, and to be fair, there are worse examples I could have picked about inconsistencies in languages. This doesn't fit programming is math, programming in logic. This more fits, people make decisions. Stuff evolves. Sometimes we have to satisfy the compiler in a certain way, and that's the reason things are the way they are. Another really nice thing about programming as a language is that some stuff is cultural. Some stuff isn't necessarily part of a language, but it just happens to be the case. So I'm from the Netherlands, and we have this very confusing way of talking to people. If we say, do you want to come over for a coffee at 7 p.m., what we actually mean is, do you want to drink coffee at 7 p.m.? That's literally what we mean. That's what we invite you for. We think we're being very clear. But if you invite, let's say, a French person for dinner, they would show up at 8, and they'd be like, where's the food? We'd be like, we had food at 6, then we had coffee at 7, what are you even doing here? So some stuff in languages is just cultural. It isn't necessarily stuck to the way we speak Dutch, that coffee at 7 means coffee at 7. It's just the way our country evolved together with the language. And you have the same in programming languages. In Python, you would write a variable in snake case with underscores, whereas in C#, you would write it with camel case. It doesn't necessarily go with the language. You can use underscores in C#, but there is a certain culture, and like with showing up at 8 p.m. on a Dutch person's doorstep to get a coffee, you would look a little bit silly if you would write underscores in C#. They're evolved in different ways, not necessarily related. These are all things that really very much fit the programming as language frame, and to a lesser extent fit the programming as math or the programming as logic frame. And of course, we have to talk about teaching a little bit, because that's what the talk was about. We can learn a lot from how we teach language to how we teach programming. That's the direction that my research is going in now. We know so much about how to teach language. We've had hundreds of years of research, and we have maybe 2,000 of years of experience in how to teach people languages. We don't really have enough experience in how to teach people programming. But because these things are so similar in different ways, we can teach programming like we teach a language, and probably it will be beneficiary to learners. Because we know a lot about how to teach a language. If you remember probably from when you were learning a first or a second language, you do a variety of things if you learn a natural language. Reading, writing, drilling words, speaking, listening, just listening to English or Dutch is already a very valid form of learning, especially for people that learn their first language. They would learn a lot just by hearing their parents and hearing their teachers speak English, then you would learn a lot. You see a variety of activities, and if you compare that to how we teach and learn programming, you see how small the scope is of things, activities we do in programming. Basically, if you want to learn programming, you practice programming. You don't, for example, read source code aloud. You don't listen to a teacher reading source code aloud. You could, but we don't. We've really narrowed the scope of activities we do with children towards you learn programming by doing programming. In language, there are these two streams of how to teach language that are sort of in competition with each other that I think we can learn a lot from if we want to teach programming. And these approaches are called the phonics approach and the whole language approach. So the phonics approach, this is the approach that we also use in the Netherlands if we teach children Dutch, is very much focused on how to pronounce letters. So we would practice the R, only the R, and then you would read a word, read. We even make this movement in schools, book. That's how you practice letters, and then words, and then sentences, and then books. That is one approach to teaching language. Another approach is called the whole language approach. And this is more popular in things like Montessori education that are more interested in what does a child want to learn and what is an exciting thing for children to do. So the whole language approach would be more to look at language in the context of language. So if you take this whole language approach to the extreme, you would just say to a 5-year-old, here's a pen, you write. They write nonsense, but they're doing fine motor skills, and after a while, they read it and they say, oh, the unicorn dances in the woods, because they remember what they wrote, not because it actually means something. And then after a while, you train this skill into being words. You can see, by the way, why the phonics approach is more popular in English-speaking countries, because you can't really focus on the letters, because I read a book is not the same as I've read a book. So in English-speaking languages, the whole language approach has traditionally been a little bit more successful than in languages like Dutch, where there's a one-on-one mapping between letters and words, and you can thus practice letters in isolation. So what does this mean if you do it in programming? So a whole language approach looks most like what we normally do when we teach children programming. We say, this is a loop, now you reverse a string. We very much focus on doing something that means something to children, that does something in the real world. Whether all 8-year-olds are very interested in reversing a string is another discussion. So what you apply it on is an interesting discussion, but mainly if we teach, we say, here are concepts, now build something. And the practice is in building bigger programs. Even though for kids that are learning, of course, the programs are still small, but they are full programs. We always practice full programs that do something useful, like reversing a string. The phonics approach, if you would do it in programming, is more like practicing one keyword in isolation. It doesn't even necessarily matter what this keyword means or does. We're just going to practice the syntax of this statement. Until you've practiced that syntax element very clearly, you can dream how an assignment looks like, and only then you'll apply it in a bigger program. And the interesting thing about language, and also math-related didactics, is that phonics is just the best approach. This discussion has been going on for decades, but research upon research upon research shows that practicing in small steps and only then applying it in bigger programs / sentences is superior over these free-form, more applied forms of learning. So this is a British article from 3 months ago, I think, where again they're stressing, even though it's not really popular in English-speaking countries, the phonics approach is a superior form of teaching. This is a newspaper article from the Dutch press also a few months ago. This is about practicing math, but it's about the same two variants of teaching math, where they say, well, it's better to practice small examples, 2 plus 3 is 5, and the tables of multiplication until you're totally sick of it, and only then do bigger programs. That's a superior form of teaching to telling children, oh, you know, we want to do, I have 12 euros and I want to buy 5 apples, and bigger, more meaningful programs / problems. So in math and in language, even though there's still lots of debates, in general, people say practicing small steps is just a lot better. So this is what we're exploring now also when we are teaching young children. So from 9, 10 towards the middle of high school, we're trying to teach them small steps at a time. We are practicing how to speak source code. In the classroom, I say, you know, repeat after me, x is 5, and the children be like, x is 5. We're practicing these small steps so that if they're reading source code, if they're actually programming, they're not spending brain cycles on how do you read this? Because it seems so simple reading x is 5, but this could have many meanings. It could be x equals 5, or x gets 5, or x is assigned 5. There are many different things that it could mean. So making sure that kids don't spend any mental energy on how source code sounds in their brain is very important. And this is especially important, we found, for bilingual kids. So we had Dutch kids read Python aloud, and they struggle a lot just how to pronounce the variable I. Because if you would read the letter I in Dutch, this letter is I. That's how we pronounced it. And we had kids read a for loop in Python saying, for I in range 0 to 5, print I. So they wouldn't even pronounce it consistently in a short snippet of source code, which probably means that in their brain, it's not the same thing either. So practicing the small step of how to pronounce source code, especially for non-English speaking children, is probably going to help them not spend effort on how it sounds in their brain if they're reading bigger programs. So we give them programming homework that is nothing like programming homework that many other people give, where you would say, indeed, this is a loop, now do something with it. We just give them fill in the blanks exercises. This is the statement, x is 5. So x blank 5, what goes there? X is blank, what goes there? Blank is 12, what goes there? Practicing the assignment until they perfectly get it, and they don't need any mental cycle anymore spent on how does an assignment look like. Think of all the energy that you have already spent in your life fiddling with semicolons or with brackets, getting it right. This is a skill you can probably, this is still research, but you can probably practice in isolation such that if you're programming, your brain is free for the bigger problems. That's at least what we think. Of course, here, I know that here also will be new naysayers, and they'll be saying, they have said this already to me, they'll be saying things like, that doesn't seem fun at all. You make it look like school. Sort of true. I mean, there is some risk in making it more boring and thus disencouraging some kids that are very excited. However, the nice thing is science, bitches. I have science on my side. Because here's a fun fact about learning that if you don't remember anything from this talk, at least remember this. How much fun children are having has zero correlation with what they're learning. Shall I say it again? There is no research whatsoever that shows that how much fun children are having actually has a correlation with how much they're learning. On the contrary, many children pick exercises that they already know how to solve because it's really fun to get everything correct. That's more fun than practicing things that might be difficult. Like it's more fun to Netflix on the couch than it is to train for a marathon. In the long run, it might be more fun to not get a heart attack, but now, you know, it's very fun to eat potato chips and watch Designated Survivor. So we as adults that are teaching, we need to challenge kids, not too much and not too little, to make sure that they learn something. If we just are going to leave it to fun, then probably what is likely to happen, what has also happened in the past, kids that can already do it a little bit, they can advance really quickly because they can do harder puzzles, and kids that are still stuck at the basic level of where does the semicolon go will never really advance because they don't have room in their brain because they're still figuring out all the symbols. So maybe it's less fun, but it doesn't matter because learning is not about fun, learning is about learning. The final thing, I know I'm out of time, this is almost my final slide. The final thing that I really like about this phonics approach, where we focus on small syntax elements and small semantic elements before doing bigger programming, goes back to the sea of reasonable beliefs. If we give children only small snippets of code, instead of saying, here's a loop, reverse a string, we give them less context about what programming is. Because if your first assignment, and I've sampled many free Python programming courses on the web, if your first assignment is reverse a string, you are already pushing children into the sea of reasonable beliefs. It says so many things. It says your code should compile. It says you must do something useful. It says there is math, reverse, and that is the scope of the things we're programming. So if we teach this small building block approach to children, what you can also do is, okay, I've shown you assignment and a print statement. What will you build with this? And it really changed my life to start asking children, but also university level students, starting to ask them, what do you want to build with the building blocks that you know? They come up with the weirdest things. I had a high school student in my classroom. I said, okay, you know some Python. What do you want to build? He says, I want to build an app for the local supermarket. It's like, why? It already has a website. Yeah, it'll be really fun because everyone can see what's for sale in the app, in the supermarket, and what the opening hours are, and this is really what I want to build. I would have never come up with a website for the local supermarket, but he was super engaged in building that. In another story, I was teaching a bunch of elementary school children, so 10, 11-year-olds, a bunch of girls, and I asked them, what do you want to program? They say, we want to build a story with a narwhal. Who knows what a narwhal is? Okay, apparently I'm stupid. I didn't know this. Apparently a narwhal is a dolphin. It's like a dolphin, but it has a unicorn on its forehead. I thought they were messing with me, but this is an actual thing that exists in the sea. A unicorn dolphin. So you can imagine, if you know any 10-year-old girls, you can imagine how excited they get about a dolphin that's dressed like a unicorn. So they were entirely engaged in this programming exercise because they could make a narwhal dance around in Scratch. And this is an exercise that I literally could have never come up with because these children explained to me the existence of a narwhal. So I could have never come up with an exercise that would appeal so much to them as this ridiculous creature dancing around in the sea. So if we focus on smaller steps, not only is it likely to get better results, it's also likely to get more inclusive results because children don't necessarily have to swim in the sea of what we think is reasonable. They can write wicked programs about things that we would say doesn't make sense, but they bring to programming because we imprint less upon them what actually matters. So with this picture of the unicorn dolphin, I want to close my talk. I'll just summarize everything in like 1 minute because I know it's late and I speak very quickly. So let me give you a few highlights to end it with. The first highlight that really matters is listen to your heart. It took me way longer than necessary to figure out that I wasn't really having fun in spreadsheets, and what was one of the things that was dragging me down is people saying, it's not real programming. I didn't realize too long, so it's important to figure out, are you still having fun? Ask yourself this question, are you having fun? And if not, do something else. The second point that's important, be aware of the water of programming. Understand that what you have come up with isn't necessarily everything that is true about programming, and especially don't be these people. Don't be, this is not real programming, please. Because it actually hurts people if you say front end or PHP or imperative programming is not programming. It matters to people. So don't be that person because it just sucks. On a more positive note, let's think as a community together about what axes there are and what programming is, and let's expand these axes even beyond what I put on the slides today. Again, if you have ideas, send me tweets because I'm curious what you think is a dimension that I missed or a point on the dimension that I missed. What we're trying to explore, and if you have children or just an interest in teaching, feel free to reach out to me. We're trying to explore, can we break programming down in tiny pieces to be more effective and more fun in teaching? That's it. I'm at Felienne on Twitter for all your tweets. I also have a blog where I regularly blog things about my own scientific research, but also what other people are doing in this space. We surely don't have time for Q&A, but there's one question I will answer because people always ask, have you hand-drawn these slides? The answer is yes, I have an Apple Pencil and an app called GoodNotes that allows me to draw these funky slides. That's it.